Okay, I'm going to do this by holding the camera in my hand and filming the screen. It would take too long to do it otherwise. Anyway, the Overton Fanglomerate is a limestone, sandstone, silt mix. And so the pictures that I show, that's what I'm referring to, even if it's not the Overton Fanglomerate. It's a mix of limestone from the Keystone Thrust. The other thing is, instead of like saying severe orogeny and get my terms wrong, I'm just going to use the term Keystone Thrust for the overthrust of limestone that came from the west headed to east. So that overthrust happened, I think, all the way up into Canada. So I'm just going to use the term Keystone Thrust. It's known that in the Las Vegas area, we're on the southern end of it. We're on the very southern end of it. Like the limestone at Red Rock, the Muddy Mountains, it's known that that's the most southern extent. Okay, so this is Razorback Ridge, east of town, and this Overton conglomerate is a thick conglomerate that it's ubiquitous. It's everywhere to the east. It's a thick coating that coats everything, and I have not heard anyone say where it comes from or how it got there. Okay, now here's a close-up. There's one close-up of it, and there's the Muddy Mountains in the background to the left. But there's a close-up of it with the huge clasts of limestone mixed with sandstone and sand and mud. Not always sandstone, but sand and mud. Okay, now these limestone blocks, sometimes they can weigh tons. Some of them are big, some are in some areas small, like that stuff there is small. But this material was laid down all in one burst. It did not come down a slope. It was not washed down by rain or monsoonal floods. This was a massive outburst flood. That is the only thing that explains this. And so, working on that premise, I reverse engineered it. Over a period of like a year and a half, I kept doing videos going, this stuff, some type of massive outburst flood occurred. Okay, now I propose that that flood was one burst and not several from the Keystone Thrust pushing over, which bulldozes material in front of it. I think the term is called morass. It bulldozes crushed material and loose material in the landscape at its base and in the front of it. And then it rides up over it. What I believe occurred was the Keystone Thrust created a dam of rubble and limestone and sandstone. It created a dam, likely in the area of the Virgin Mountains. And the dam eventually broke. The same concept of the Ice Age floods. It's also known that the overthrust occurred in such a way, coming downhill, coming down a slope, and that some of the overthrust flowed around existing features like existing mountains that flowed around them, very similar to the concept of a glacier, except a glacier of stone. Okay, so as I think, I'll stop recording. And now here's another block. These blocks fell down from up above on Razorback Ridge, and a lot of them are bigger than houses. But this coating of what I'm calling the Overton Fanglomerate, in some places it's thinner, but in some places it's very thick. As a matter of fact, in the Muddy Mountains right there in the background, in some spots it's 2,000 feet thick of this rubble. Okay, so I'm going to stop recording now and go to the next point. In this conglomerate, when you inspect it, all over a vast area, by the way, there's no stratification except what would occur during a flood. In other words, there's no stratification as if there were several floods or monsoonal rains or seasons that came and went and put this down in a layer. All of this material, wherever you see it, is always one massive outburst that occurred all at once, likely within days, possibly within hours. This is just another view of some showing that in some spots the conglomerate is almost all limestone. But invariably it does have some sand and clasts mixed in with it. Some of the sandstone clasts were lithified or partly lithified, but a lot of them weren't. In other words, when this flood occurred, it washed this material, a lot of which at that time wasn't stone, fully stone. Now this one is right up there next to the highway, and that's Razorback Ridge on the upper left. This one is mostly sand, and it does have some clasts in there of sandstone, but this one is mostly sand. Also, this material can vary from mostly limestone to mostly sand in a very short area of less than a mile. This picture was taken at actually the top of a small mountain near the highway. So the top of the mountain, of course, was the surface at the time, even though around the mountain the material has been washed away. But the point of this picture, notice these clasts of, in this case, partly lithified sandstone that was in it. See how that looks? Now there's some other chunks, some clasts of sandstone that apparently was lithified. If not, it will be a mix. It will be all mixed in. But you see this one, see the shape of that? That was not a flood of rain. That was not a stormy night that did that. This was a massive outburst over a vast area of hundreds of square miles. I took this picture on the same day, as a matter of fact, to show that talus slope of the scree coming down, theorizing on the Keystone Thrust that would have been thousands of feet higher coming across the landscape, that this ubiquitous Overton conglomerate somehow tumbling down the hill. It was too coarse and too big for it to be like washed. And so I took this picture, and also there's a PDF about the area that theorizes that it likely was so steep that the material came down a very steep hillside. Okay, well that does not explain how this perfect coating covers the land, a vast area. It just doesn't explain it. So that's why I took that picture. That this theory of it coming down a steep slope, it doesn't work. Okay, don't try to pay close attention to every detail of the map. Okay, now the Keystone Thrust, see here's part of it there. See how they come across in waves, almost like a glacier? That's some of it, and there's the area of the area of Red Rock, you know, Keystone. Okay, so you've got some overthrust there, and also over here, the Muddy Mountains, it's known that it's overthrust. And so remember, the Keystone overthrust ended, let's say, 80, 90 million years ago, just as a number. Okay, so it ended, and so these were much more massive. They were connected, and they weren't stretched apart because of the stretching apart of the land that gave us our basin range. The basin range, some of these limestone mountains are uptilt, are upthrust and uptilt, but some of them aren't. These are examples here, this overthrust. Not all of our limestone is upthrust from our basin range extension. Okay, now, so we already know that this is the southern end of the overthrust. the Muddy Mountains, the area of Red Rock. It's known, it's documented that that's the very southern part of it. And it would have come over about where I'm pointing the camera now. That's Lake Mead and the Overton Arm that goes up. Now remember that this was 50 million years ago. Let's say 60 million years ago. Let's use the end of the dinosaurs as a reference point. That would have been the perfect zone of time for this dam of rubble, of limestone rubble and sand to break. In other words, you can assume like the time when the asteroid hit that helped end the dinosaurs, but I'm not saying that that is definitely what triggered it, but just use that as a reference of time. And so now this area back then, it's known that up there towards the north was the inland sea, and it was tapered, it was going away, but it was hundreds of feet thick. And so we already know that this area here, the left, was very high mountains of the overthrust. That was high mountains. We already know that this area was a huge trough because it was the inland sea. And it was not just a shallow pond, it was hundreds of feet deep. So we know that that was a trough. That's given. And we know that this area over here was highlands. Now, the Virgin Mountains there, I don't know the geology of them yet where I'm pointing the camera. I don't know how high they were, but we do know that you had highlands here, highlands there. The water was there. It was a trough of the inland sea, and that the conditions were perfect right in this area for a dam to exist. Now, the water that was backed up, did it have anything to do with the inland sea or fresh water? I don't know that. I don't know that yet. But the conditions right here in this area were perfect for a rubble dam of limestone to exist. And then because of the flow, like when it burst, because of the flow of the material, you can tell that the flow was from up here, and maybe a lake went over here or over there. I don't know. It didn't have to go straight up. Who knows where it went? But when the water came through, it washed the material from north to south. That's known because of the location and the depth of the conglomerate. Okay, when the asteroid hit 65 million years ago, the Yucatan Peninsula right there, I don't know. I can't be sure, and I'm not saying that I know that the hit of the asteroid and the earthquake is what triggered the breakage of this dam. But it could have. This distance is not very far. It would have been affected by the earthquake of the impact. Also, suppose this meteor came in from this area to this area. Well, could it have caused overpressures? You were saying. And blasted the water, blasted the dam, and triggered a dam that was maybe ready to burst anyway? Maybe it triggered it? I don't know. I'm not saying that. I'm not an expert. Okay, this massive flood that I'm proposing, the material would have come down this way, the water and the material. But the flood, it could have been a long, slow flood. In other words, a massive sheet flow. How do we know that that flood was like the Ice Age floods up in the Northwest that came down canyons, ripping out things thousands of feet deep? It didn't necessarily have to do that. It could have been, depending on the land back then, it could have been a massive sheet flow of rapidly moving water that blasted stuff along, especially because of the way that the limestone rubble of the conglomerate so evenly coats the landscape. So the question is that using this as a theory, could a person go someplace, for instance, down here near the Gulf of Baja, could a person go there and dig or drill or whatever and locate the smoking gun. In other words, chunks of limestone that wash there. I just don't know that. That's for the experts to start looking at things like that. Okay, this conglomerate material, could it have traces of things in it like iridium or shocked quartz or stuff blasted out during the asteroid hit? It's not impossible. It could. Iridium wouldn't be there because these are flood deposits where iridium would be concentrated like on the surface. You wouldn't find it in this stuff. But could it contain chunks of material blasted from the Yucatan Peninsula? It could, but a person doesn't want to become obsessed with that because there's no saying, even though it's interesting, that the dinosaur asteroid is what triggered this dam collapse. It could have been, but this collapse of this rubble dam, it could have been 10 million years before. It could have been 10 million years after. So, but things like that. Suppose this does show up some shock quartz. Well, that would be huge.